Now, in the today's class, we are discussing jet transform and ROC of infinite duration signals. In previous sessions, we discussed for finite duration signals. Now, we are going to deal finding the jet transform as well as ROC for infinite duration signals. So, for this case, we are categorizing into three cases. One is positive time exponential sequence, and second case that is a negative time exponential sequence, and third one is that is double-sided exponential sequence. Let's see one by one. First, I will take positive time exponential sequence. So we are getting what? The time is positive as well as it is of exponential kind. Nothing but we can consider a signal that should be what? Exponential sequence as well as that should be positive time. So a positive time exponential sequence is going to define as x of n is equal to a to the power n u of n, where a to the power n is an exponential sequence, of course, correct. Then we are this part is that indicates the a to the power n. Then coming to the positive time is indicated by u of n. So x of n equal to a of n, a to the power n multiplied by u of n, that will indicate x of n. Nothing but x of n is about, this is nothing but it is a positive time exponential sequence, because we know that uh, u of n is equal to 1 for the time n is greater than or equal to 0. Nothing but it is positive time, else it is 0. So positive time is indicated by u of n, exponential sequence is indicated by a to the power n. Hence x of n is a what? It is a positive time exponential sequence. So for this sequence, we have to calculate jet transform as well as ROC. Let's see. I am going to write the definition of jet transform. X of z equal to summation n equal to minus infinity to the power minus infinity to plus infinity x of n multiplied by z to the power n. So this is what it is, the definition of jet transform. Now in this definition, I am going to substitute the value of x of n here. That is x of z is equal to, okay, summation n equal to minus infinity to plus infinity. X of n is what? It is a to the power n u of n multiplied by z to the power minus n. Very simple. Here we already written the definition of step signal here. If you are replacing u of n by 1, then we have to write the condition, because u of n has amplitude 1 for n is greater than or equal to 0, correct? Okay, fine. So by using the definition of step signal, I am going to rewrite the in limits as summation n equal to 0 to infinity a to the power n z to the power minus n. Okay, fine. Now I'm going to simplify this part. Okay, let's see. I'm going to simplify this part. Here a to the power n as it is, z to the power minus n I can write like this, z to the power minus 1 power n, or we can write a to the power n as it is, z to the power minus 1, that one we can write 1 by z to the power n. Here for these two parameters the power term n is common, so we can write a by z to the power n. Okay, a by z to the power n, likewise we can write, correct? So now by using this simplification, this becomes, the above equation becomes x of z equal to summation n equal to 0 to infinity a divided by z to the power n. So let us simplify by using this formula. Already we discussed many times. We know that one standard summation formula, that is summation n equal to 0 to infinity a to the power n. This one we can write 1 divided by 1 minus a. Condition is what? Mod of a is less than 1. It is the condition. Mod of a is less than 1. By using this formula, let us simplify this equation. That is x of z is equal to 1 here, here a equal to what? A equal to a by z. Okay, 1 divided by 1 minus a divided by z, because 1 divided by 1 minus a is there. A equal to what? A by z is there. Here I written. So further simplification, x of z equal to, take the LCM. So LCM is z, z minus a divided by z is there. That z will go to the numerator. Hence we can write z divided by z minus a. This is the what? It is the z transform for the given positive time exponential sequence. It is zt. Fine. Let us go for calculation of ROC. So we got this jet transform. The existence of this jet transform is only when for this condition. Only for this condition, nothing but mod of a is less than 1. We got this result by using this formula, correct? In order to use this formula, what is the condition? Mod of a should be less than 1. Here a equal to what? A equal to a by z. That is mod of a by z should be less than 1. Okay, hence if you take z other side, so we can write mod of a is less than mod of z. Hence ROC is what? ROC we can write mod of z. So the same equation I can write z is greater than a, correct? Mod of z is greater than mod of a. This is our ROC. Nothing but, so from this condition we can tell that ROC lies on the z plane. It is z plane, right? ROC lies in the z plane outside the circle of radius a. So how to sketch this one? Here I am going to sketch. Okay, here I am going to sketch the ROC on the z plane. This is z plane. This is what? It is the imaginary part of z transform. It is the real part of z plane. Okay, now I am going to sketch the what? Circle of radius a. I am going to sketch circle of radius a. Okay, so this is what? Radius is a. Now this is virgin. Okay, fine. Now already I told the numerator polynomial will indicate the zeros, and denominator polynomial will indicate the equating the numerator polynomial to the 0 will give the zeros. Equating the denominator polynomial to the 0 will give the poles. So first I will sketch ROC. ROC is what? ROC lies outside the circle of radius a. Hence it will lies outside the circle of radius a. This is our ROC. This shaded part will give the what? ROC. This is our ROC. Okay, because it lies outside the circle of radius a. Next, go for calculation of zeros and poles. Let us indicate the zeros and poles on the z plane. Simple thing, equate. Here I will write zeros. Equating the numerator polynomial to the 0 will give zeros. How many? Only one term is there, so 1 0 is there. That is indicated by z1. Z1 indicates that 1 0. Equating the numerator, that is z is there, to the 0. So what we got? We got 0. Hence this point is what? This is z1. Okay, this is z1. It means 0 at origin. Okay, 0 at origin. Next go for finding the poles. Nothing but equating the denominator polynomial to the 0. So poles is indicated by p1. Equate z minus a equal to 0. Hence we can write p1 equal to z equal to a. Nothing but pole is present. One pole is present where? At a. A means this is point is a, radius is a. Hence poles are indicated by cross mark. This is our pole. Okay, this is, we can write pole at z equal to a. Hence, successfully we calculated z transform for the given positive time exponential sequence, as well as we calculated ROC. Then we represented zeros as well as poles on the z plane. Okay, this is about first case.